So hello everyone and welcome to episode 11 of Echoes from the Field. Today I'm delighted to welcome Max Brouwers of Getech. So welcome, Max.
Thanks very much, Mike, and it's a great pleasure to be here today.
Thank you for joining us. It's a very hot day here in the UK, so if we start sweating, that's why. It's not nerves. I wonder, Max, if you could start by maybe giving a short introduction to both yourself and Getech, who you currently work for.
Sure, yeah. And before I start, actually, congratulations to Stride for the launch of Hilo, your new mode system. I think that's a great addition, and yeah, I'm sure will serve you well. So myself, I'm geologist by background, been around 30 years in industry, 25 of that with Shell, where I've been holding a variety of different exploration roles, technical, commercial, leadership roles. And in the last 5 years, I've been with Getech. Getech is a natural resource company. We help other companies locate resources, oil and gas, critical minerals, geothermal. We use our unique data, our software, and capabilities.
Thank you very much. Now, I understand you started your career as a seismic interpreter and later in your career led exploration across several major global regions. How's your view of what's good exploration, if I can put it like that? How's that changed from early days to the kind of investment level decisions you advise on now?
Yeah, good question. I don't think there is, if you like, a significant change, but the emphasis has certainly moved over time. Where in the beginning, the focus was primarily on, is my technical interpretation internally consistent? Does all the data line up? Sure, there was at that time already a focus on does it make economic sense to invest in this particular opportunity? But I think that has certainly strengthened over the years, or if you like, over the decades, where there's now really a focus on maximizing value over the full value chain. So I would say geoscience is still very much a core building blocks, but other items have been added to that, such as indeed the economics, which I mentioned have gotten more prominence, but also managing stakeholders, getting them aligned around opportunity. And clearly technology has advanced as well. So things which in the past were not possible are possible now. Thinking of casing stacks in the deep water or unlocking shale gas. I think the basics are still very much the same. You need to understand your data. You need to come up with a proper proposition, but it needs to meet many more hurdles at this moment in time in order to be good exploration.
Okay, thank you. Now, Getech often sit right at the front of the exploration funnel before companies, for example, commit to detailed focused seismic. What, in your view, are the most important questions operators should answer before they start spending money acquiring new data?
Yeah, that is a good question as well. I personally think that sometimes companies jump too quickly to acquiring new data, whatever type it might be, without fully maximizing the information they have. And actually, maybe the information they have or other potentially older information which still might be out there. Overall, I think there's quite a focus on seismic and for the right kind of reasons, but there are other types of seismic like gravity and magnetics, for example, but also or well reports, which all have some, if you like, insight which needs to be fully extracted, because usually thinking is cheap compared to acquisition, which of course takes time, there's money involved, safety, exposure, etc. And what I also believe is not happening necessarily enough ahead of potential acquisition is considering the value of information, of that new information versus the cost. So simple VOI exercise, what am I expecting to get out of it? How does it compare to the cost? Does it really tackle the key challenges which you have? Can give a lot of insight that helps to make, I think, more informed decisions.
Sounds good. Thank you. And I guess leading on from that, in onshore exploration, the temptation for some people is to go and acquire large, quite sparse surveys to kind of cover an area with lots of uncertainty. Whereas I believe working with the likes of yourselves, you can do kind of smarter screening first. And how would that kind of smart screening change the eventual seismic survey compared to a relatively blind, large, sparse exploration over an area?
Yeah, I think indeed the standard solution, the easy solution is, oh, let me just cover that and so I get a data point everywhere, and that provides me at least some insight. Given that nearly every point in the world has been looked at in the past, and there is, in most cases, gravity and magnetic and old wells, even if it's water wells or seeps or whatever it might be, type of data available. I think doing a full study upfront with all that existing information will really help to highlight which areas are most attractive. And then with the same money or potentially even with for less money, a much more focused acquisition, which really targets the most prospective area can be acquired. The benefit of that is that when you do potentially a very sparse data set just to cover everything, you still might need to go back afterwards and do a more detailed survey to really make sure you have a proper structure identified because you really want to drill on that location. If you do that an additional survey up front, time effective and less time in the field, which of course from a safety point of view helps as well.
You said something really interesting at the start there. Most of the world has some form of geophysical data, I think you said. Roughly what kind of percentage is covered?
Yeah, it depends, I guess, in what level of granularity, but I would say there is data everywhere. Gravity and magnetics data is effectively everywhere. It's just, okay, how far do you need to extrapolate from a particular kind of measure point? So we have insight in many places, and in many cases, data continues to be acquired as well. And that's again, of course, from a Getech point of view, where we can help clients is we can provide that initial perspective with our GravMag data, with our knowledge database called Globe, which has nearly 50,000 different layers of Earth history, which allows to get a very quick overview of any kind of location in the world, or literally anywhere in the globe. What is the potential prospectivity here for any type of national resource? So, of course, we might be tempted to talk in this conversation. I have very much oil and gas back up on mind, but I think we see quite broadening of interest these days. Critical minerals, especially rare earths, are all over the place. Copper, of course, is more needed, but we see also geothermal coming up quite a bit. And then hydrogen and helium as resources. I think for all these type of exploration, we can provide a really good starting point, and based on the evaluation of that existing data, then help target 2D, 3D acquisition, of course, potentially using your systems as a way to advance that exploration effort.
Yeah, and I don't think we should focus just on oil and gas. We see the same trends you've just described. So about 2/3 of our projects are non-oil and gas, actually. We definitely see that trend of we're seismic, but seismic being used very broadly. And it sounds like you see the same. So let's try and cover everything as we go. So we haven't mentioned our collaboration yet. So Getech and Stride have a partnership, and the first bit of work we did was in the Middle East. And your screening insights were actually used to provide a much more focused area for 3D seismic acquisition using a Stride system. In your view, what made that project a good example of how that early subsurface intelligence can move an operator from regional uncertainty to a more targeted investment decision?
Yeah, I think that is indeed a great example of our collaboration and how it really adds value to clients. Of course, due to confidentiality, we can't say too much about the specifics. But the bottom line really is we save that client quite a lot of money and time by effectively what we discussed before, really using first all available data to do a proper high grading of the large area which they were evaluating for a particular national resource. And on that basis, start to say, okay, these are the focused areas, the areas where we see the most prospectivity. And rather than doing the 2D broad, sparse type of acquisition as which you were highlighting earlier, we could really point this particular client to say, okay, these are the 3 areas where you really want to focus on and have a much more dense, high quality 3D, which allows you to also, for the next steps, to accelerate your project. And yeah, as you've seen, Mark, the client was really happy with that. And it's a model which clearly is working with that case study, and others can benefit from that approach too.
Sounds fantastic. So Max, when you're integrating gravity, magnetic, geological, well and seismic information, what signals tell you that an area is worth high grading rather than just being geologically interesting?
As a geologist, you find a lot of things interesting. So that is indeed a key. I think it goes back to the fundamentals of what exploration really is about. First of all, as we said before, you need to understand, of course, what resource you're looking for. And for that particular resource, and let's say it's sedimentary copper, epithermal gold, hydrogen or whatever, there's usually one or a few genetic models which people have developed, and it is understanding what are the key criteria of that genetic model, and then you start looking in all that geological and geophysical information if you find the right kind of hints for it. And that usually, again, think of play-based exploration, things like, is there sufficient indication of a source rock? Does the migration path is that there towards a potential reservoir? Is a trap there? And are all those elements in the right kind of sequence? And did the trap form before my hydrocarbons start leaking out, for example? And it is based on having sufficient confidence that the genetic model actually can work in this particular case. Then you can start saying, okay, this becomes really interesting. Ideally, you find some additional deterministic points which gives confidence to that particular exploration model. But that's usually from the type of evaluation which we're doing to help high grade an area for subsequent seismic acquisition, the right kind of approach. Is an area really favorable for the individual play elements? And if so, then it might be the right place to look in more detail and acquire a seismic survey.
Okay, thank you. Our partnership, so Stride and Getech's partnership, we're really connecting basin evaluation, geoscience intelligence, and then, if it's appropriate, nodal seismic acquisition. From your perspective, why is that link between where to look and then how to best image it so important for onshore explorers?
Yeah, it is not, of course, only the area where you want to acquire seismic, but as you know really well, it also depends how you acquire it. What kind of a layout do you use? How deep, how long do you let your nodes run? So you really need to understand what you're looking for in order to optimize the design of the survey. And again, given the amount of value which goes, or money which goes into acquiring, you better put in that a little bit of additional effort to really make sure you design it properly up front, because usually you have only one shot. Quite often people are constrained, clients are constrained in time because they need to drill a well and by date X. So yeah, I think measure twice, cut once, as the English expression goes, is the right kind of thing with these kind of things. So again, doing the study up front, where to look, what you're exactly looking for, what is the key uncertainty you really try to address with the seismic acquisition, helps you to design the acquisition in the right kind of way, so you have the highest chance of polarizing that key uncertainty.
Makes sense. Now in your career, you've worked across oil and gas, carbon capture and storage, hydrogen, geothermal, critical minerals, as you said. What's common across all of those in terms of subsurface challenges, and where does maybe the exploration mindset need to change between those industries or resources?
I think maybe starting off with the exploration mindset, in my view, is an interesting one, because an explorer sees uncertainty as an opportunity. There might be something there where the average engineer or the average lawyer, no offense, sees uncertainty as an issue, a risk that absolutely needs to be removed. I think it is the creativity of an explorationist which in that uncertainty can see, hey, something might be here or something might be potentially possible if I use this kind of system. And I think a key point in that, in the exploration mindset, is absence of evidence is no evidence of absence. That's one to really think about. And it actually is maybe used generically around explorationists for quite some time, but it actually comes very strongly back now when we start thinking about AI or machine learning, and particularly because some of the algorithms are really based on that. The presence only prediction is one of those very specific algorithms which we use to really make sure if you have evidence of something but somewhere else we don't, it might be the uncertainty rather than the proof that that particular resource might not be there. So if you talk about what needs to change, it is translating some of those kind of generic kind of concepts more into what does that mean and how do I use the latest kind of tools and techniques, like, for example, machine learning, to move exploration forward and in a way, use that technology to embrace that uncertainty. I think what further has changed is actually not only in machine learning, but I think as science continues to develop in many different kind of, there is still somebody who needs to bring all that together. That might be indeed continuous advances in seismic processing. It might be machine learning. It might be other elements. They all have something valuable to contribute. And a good explorer is able to integrate all that, not necessarily the expert in all those individual elements, but in that way come forward with the most probable occurrence of certain kind of resources in a particular location.
No, that all makes sense. I guess the one bit we didn't touch on, in my mind, there's quite different budgets potentially between those industries, which that's more forcing constraints on you. But actually what was interesting in our experience, I'd expect oil and gas to have the largest budgets typically, and that's where we tend to see the densest surveys. But actually some of the other industries which economically might look to have less margin to play with or less money to play with are actually doing really high quality seismic. So we're seeing, say, one of the largest or projects that maybe 10 years ago would have been huge in oil and gas being done for CCS and increasingly for geothermal. I don't know if you're seeing something similar in what you do or not.
Yeah, we clearly do see, of course, that there is a difference in budget. But what I do see that the most successful companies in those other sectors, in those emerging sectors, do value high quality data. So rather than rushing it or getting away with, okay, we'll do the cheap way now, they do appreciate how important it is. And again, they might measure twice before cutting once. So do a little bit more pre-work. So they really feel like optimize the size and the acquisition. But in the end, the price is out there and it can only be found by good scientific research and using the right kind of technologies, the right kind of seismic acquisition quickly into it. But they are indeed making use of the latest technologies in order to find whatever resource they're looking for.
Yeah. Thank you. Going back to your experience at Shell, you were leading exploration and energy transition activity as well, I believe, across several countries. What have you learned about getting everyone aligned? So your technical teams, the executives or the decision makers, governments, partners, how do you get everyone aligned around that subsurface risk? I imagine it can be quite challenging.
It is challenging, but I think that's a nice challenge. I think clarity and communication is the key thing. Being able to very objectively paint a picture of what the opportunity can be, but also outlining the unknowns. So don't if you like, promise. I've seen examples where, for example, the upside was not properly weighed. The focus was way too much on this one individual opportunity. There's a lot of uncertainty around it, and the decision was not to invest in it. And in the end, a whole deep water basin was missed because the broader what if kind of picture was not properly considered, not properly constrained. The other way around as well, I've seen it also, where people were too much believing, hey, this is so fantastic, this is so great, I've got all the evidence, and I think confirmation bias starts coming in, and actually the breadth of unknowns were not properly represented. And it is usually, I think, humbleness in what we really know and what we don't know, and it's usually the unknown unknowns that get us in exploration. So that comes back to that whole exploration story, being able to outline, especially then to decision makers, individual experts, but also the broader stakeholders, what could be the benefit to them in a broader kind of sense. Maybe slightly more narrow with regards to acquisition and local stakeholders, early engagements, taking away the fear of what might happen, potentially bringing some local benefits to them. Could be a water well, could be restoring something else. Usually have infrastructure capabilities around anyway while you're preparing for seismic and or drilling. So really make sure that they feel a personal benefit next to, of course, the hassle of having a seismic crew come along. So yeah, communicating, being clear, listening, and being honest in what you know and don't know, that usually is the right kind of approach in my experience.
Thank you. So at Getech, you use geoscience, a great data set, market-leading data set, geospatial insight, some AI and ML-driven analytics, and you combine those to unlock subsurface potential. How do you balance machine-led analysis with kind of human expert geological interpretation when your decisions are high value and high risk? So
yeah, again, a great question. And it is, of course, evolving all the time as the AI and ML capabilities get better. So what we certainly already do quite a lot is using AI to accelerate our workflows, simplify tedious tasks, so things get more efficient and potentially also less errors for the very repetitive type of task. Where AI is maybe not yet fully developed, where there's still certainly more help needed, is in the more predictive kind of capabilities. And that is, of course, where hallucinations can occur, and that's where expertise really needs to come in. So I think it is really the combination of leveraging the capabilities which AI in the broader sense brings to really push the boundary. AI is great in creating a lot of ideas and opportunities, but then the true subject matter expertise still needs to come in to do the quality assurance, making sure it really works. And what we see more specifically with machine learning, it is really the supervised machine learning type of approaches where you give it clear boundaries, the physical kind of constraints on what can and cannot happen. That is where I see the biggest progress at the moment, and where it's helping us to identify resources in locations where people didn't expect it. It is really that synergy. Don't be too afraid of using AI, but be cautious at the same time as well. Trust but verify. Throw in another expression is something which I think is the right way to work with AI.
Makes a lot of sense. My last question, possibly the hardest one. As you look ahead, what do you think the onshore exploration workflow will look like in, say, 5 years' time? Do you think that it's going to change, or do you think it'll be broadly similar to how it is today?
I think 5 years is a relatively long period, and quite often technology in a very short time, you say, okay, there's a small incremental changes, but actually they do compound. So over 5 years, the compounding effect, I think, will be material. So what I will expect to see is that there will be even more different types of data available, from remote sensing to your next version of Halo to advances in GraphMap. And all that additional data provides new insight, and being able to bring that together and extract new insight out of it. That is where I see the biggest change or advancement. The other thing which I think we start seeing already now, but which in the next 5 years I think will get more prominence as well, is the exploration for multiple resources at the same time. Think about geothermal and lithium, for example, or oil and gas plus helium. These 2 or potentially 3 different types of resources which can be extracted at the same time. And I don't think we've fully gotten our mind around how to properly do that, but as we have that additional information and we bring different natural resource sectors together and integrate it, I think that's where we can make a lot of progress as well. So yeah, in that sense, I think there's a lot of work and a lot of business to be done in order to provide the world the resources, the security of those resources in a safe and environmentally friendly manner.
Yeah, I certainly see the same opportunity of one data set helping multiple resources. I think there's real opportunity there. I guess the other aspect I'm expecting, and we're seeing this already, is a faster workflow. So end to end. Some stages are still finite time. Permitting, for example, will have, unfortunately, a finite time depending on where you are. But the acquisition's faster, the processing's faster. I think the interpretation will get faster as well, which overall is good for everyone. It lets you go from that initial investing time and effort to being able to make an informed decision much quicker. Yeah. Well, thank you, Max. We've covered a lot of interesting ground today. Is there anything else you'd like to cover which we didn't get to?
I think there's nothing specifically which comes to mind. I think the integration ourselves is indeed the way to go. And yeah, thank you for the opportunity to be here as a guest for this webinar, and look forward to our continued collaboration.
Yeah, likewise. Thank you very much for joining us. And I'm sure the audience will have gained a lot from our discussion. One last question. What's the best way for people to reach out to yourself or Getech?
info@getech.com.
Okay, perfect. So drop an email there and get a discussion started.
Or look for our website, but if you want to drop an email, have any further follow-up questions or comments, I would be more than happy to receive those.
All right. Thank you very much, Max. And hopefully you're not too hot at your end. It's warming up here, so I'm glad we chose the morning to do this.
Indeed. My pleasure. Thank you.
Thanks very much.